Dear first year, first semester students of Department of Physics of Shahjar University of Science and Technology, now I am going to deliver the 8th lecture on the course Mechanics, course code PHY 121. Today we shall discuss about work. Actually the whole topic is work and energy, but today we will only consider work. First of all, I will explain three concepts that are related with work. The three concepts are: number one, work; number two, energy; number three, power. The concept, physics concept of work involves a force when the application point moves some distance. So try to understand that it is not only force what is matters. The force has to move something some distance. Say I have a body here and I am pushing it with a force F, and if that body moves some distance S, then we say that work is done. If force does not move something, force will not be there. So the physics concept of work is related to two things. Number one, the force; number two, the displacement. This is work. Then comes energy. The concept of energy is the capacity of a system to do work. So energy is the capacity to do work. Work is something, and upon work energy is defined. If somebody, if some instrument can work, then we say that that thing has energy. The third concept is power. It is the rate at which work is done. So the third concept, power, means a body can do much work in a short time, another body can do the same work at a longer time. So power will be different. In these two cases, the rate will be different. When the rate of work of two bodies doing the same work is same, the power are same. So now let's go to define work quantitatively. First of all, we should consider only constant force. A block of mass m is raised by a winch operated with a motor. A block of mass M is raised by winch operated motor by a distance h in the vertical direction. So the figure will be what? Say, this is the winch. I shall not show the motor. Here is the block of mass M. So the motor, while the motor operates, the block raises up. The block goes up. So here is the force, we call this force T. Also, the body has mass M, so a force or weight of the body mg will act downward. Right? Now, we assume that the body, the block is raised with no acceleration. That means with uniform velocity. The block goes up with uniform velocity. When it goes up with uniform velocity, it has no acceleration. So the block is assumed to go up with constant velocity. So acceleration of the block is 0. Since acceleration of the body is 0, force on the block is 0. Force on the block is 0. Acceleration is 0, force 1 is 0. So, what are the forces here? Upward T. I should not write the magnitude. I shall write only the magnitudes. Upward force is T. Downward force is mg. So downward, since downward, I shall put the minus sign and write mg. These are the two forces acting on the block. Upward T, downward mg. The minus sign indicates that mg force acts downward. Plus sign before T means that T is pointing upward. And the sum of these two is 0. If this is not 0, then there will be acceleration. If this T minus mg is 0, there will be no acceleration. The body will go up with constant velocity, uniform velocity. So, next step, we can write T equals mg. Right? T equals mg. Now it will be easier for us to define the force, the one exactly. Work is symbolized by W. Work is symbolized by W. We define the work W done by a constant force F that moves a body through a displacement S. I remind you, displacement is always a vector. As force is vector, displacement is also a vector. So I write S and give an arrow overhead. S in the direction of the force. So here two conditions. The force is constant. The force is moving a body by displacement S in the direction of the force. Here what is done? What is here? The force and the displacement are parallel. In this case, W is equals F S. Now I write the magnitude of the force and magnitude of displacement. F multiplied by S gives the work. And the condition is what? I write the condition here. Constant force and F and S are parallel. F and S are parallel. So come to the point of the first figure we have drawn, where the block of mass was raised. Say, I draw the figure again. Here is ground, this distance is h. Here the tension force is equal to mg. Tension force is raising that force T is raising the block up. And in moving from ground to this distance is h. How much work is done? T multiplied by h. T multiplied by h. H is the displacement here. And that parallel. T is upward, h is upward. T and h are parallel. So the work will be T multiplied by h. And you can write T equals mg. So here W equals T h equals mg. You will find this formula mgh in many cases where gravity is involved. You already know that this is the potential energy difference in gravitational field of our Earth. You know this. Okay, that's not our concern right now. We are concerned with the work. And here in this example, the work done is mgh. The condition is what? The condition is the force and the displacement are parallel. The force is constant. Okay? Next, we shall consider unparalleled force and displacement. The force and displacement are not parallel. What will be the work in that case? This is now our question. For that, I will have to draw a complicated picture, a diagram. Please be patient and try to understand what is drawn. In an inclined plane, I shall first draw an inclined plane. Here is a block. Here is a block resting on the inclined plane. Here is a block resting on an inclined plane. The figure is understandable, right? Discernible on this hand. The block is on an inclined plane, and now consider a block on an inclined plane and a force F is applied parallel to the ground. That means what? The force is here in this direction. F. This is the ground. Parallel to the ground, the force is applied. Now, this force has two components. This force has two components. One component acts along this line. If this angle is theta, this is F cos theta. How do you know that? That this will be F cos theta. I give you a trick to find out what will be the component along that inclined plane. Parallel transport the F here. Parallel transport the F here. So F. I have parallel transported the force to the bottom. Now, what will be each component along this line? The angle between this and this is theta. So the component of F in this direction will be F of cos theta. So see, this is a simple trick. Whenever you are baffled how to find the component, just parallel transport one vector to another place and you will easily find out the component. And there is another component which is perpendicular to say this is to the if I prolong this will go this one and this will work downward. This is F sin theta. Right? Now the question is where that F sin theta helps to raise the block up. The answer is no. Because F sin theta has no component along the inclination. F sin theta has an angle of 90 degrees with the inclined plane. F sin theta has no component along the inclined plane. So F sin theta will not do anything in raising the block. Whatever work is done by the component F cos theta. Now, say a distance of S is involved here. That means the F cos theta raises the block by a displacement S. Now, F cos theta and S are parallel. F cos theta and S are parallel. So our previous formula can be applied here because here now F cos theta and S are parallel. Previous formula will suffice. So we can write them here. W equals A cos theta multiplied by S. F cos theta multiplied by S is equals A S cos of theta. So whenever two things, the force and the displacement, are not parallel, even then you can define one in a appropriate way. You have to take the component of force along the displacement. You have this F cos theta. F cos theta is the component of F along the displacement. Right? So now we shall discuss some features of this equation. W equals Fs cos theta. Some features of this formula F cos theta. Some features. Number one, if F is 0, W is 0, right? Number two, these are obvious. If S equals 0, W is 0. So this is very important. You have a force. If it does not make a displacement, if it does not push something to some distance, there will be no work. Only F, the force, is not sufficient. The force has to move something by some distance. Only in that case, work will be done. So, whenever S is 0, W is 0, means displacement is a must, otherwise W will be 0. Okay. Number 3, if theta equals 90 degree, F equals W equals 0, right? Say cos of 90 degree is what? 0. Cos of 90 degree is 0. So W is 0. When theta is 90 degree, W is 0. What is this? Come to this point. Here, put 90 degree, this is 0. The whole thing, F cos is 0. That means what? You have to have a component of force along the displacement. You have to have a component of force along the displacement. Otherwise, the work will be 0. Number 4, when theta is 0, W is Fs. This is the first formula we have written down. When theta equal to 0 degree, then W equals as parallel force and displacement. Parallel force and displacement gives a simple formula. Multiply the magnitude of force by the magnitude of displacement, you will get the work. W equals Fs. This is the case of parallel force and displacement. Number 5, this is something tricky. When theta equals 180 degree, W negative equals minus Fs. Because here 180 degree, cos of 180 degree equals minus 1, W equal to minus Fs. So we shall give an example of this. When W becomes negative, what may be negative? How? Come to the first diagram to draw. The winch and the motor. Here, consider only mg. Mg is working here, right? Mg is working here. From ground, the distance, this distance is h. MG is working downward, displacement is upward. What is the angle between displacement and the force? 180 degree. MG working downward, but the displacement is upward. The direction are opposite. Theta equal to 190 degree, 180 degree. Then what will be the force? What will be the work? Work will be minus Fs. In this case, W equals minus Fs. What is F? Minus mg. What is S? H. So, here the weight was a negative one given by minus mgh. So, we have covered all the features of this formula, the previous Fs cos theta. Now, we remind you that you can always compute work in two ways. You can compute work in two ways. W equals F S cos of theta. You can write this F multiplied by S cos theta, or you can write F cos theta S. That means take the component of displacement along F and multiply it by the F, or take the component of F along S and multiply it by the S. In these two ways, you can compute the work. So this suggests there must be a component of F along S. This is first. There must be a component of F along S. Also, there must be a component of S along. These two should be fulfilled. S displacement has to have a component along direction F. Also, F has to have a component and direction of displacement. Otherwise, work will not be done. And now we shall pictorially see these two things. Say this is a particle. And a force is working over this. This is F. The displacement is this. Okay? This is the displacement S, this is the force F. Now, one more to compute what? Take the component of F along the direction of S. So, draw the perpendicular on the line of S. So, what will be this? This will be, if this angle is theta, F of cos theta. This is F of cos theta, right? This is our cos theta. And then those are the component, we need not write it f sin theta. So here W is what? F cos theta multiplied by S. Here the formula is like this. We interpret here that the work is done and it computed by taking the component of F in the direction of S and multiply that component by the displacement S. Second method, say this is the S and this is the force, here is the particle. Here is the particle, this is F. And this angle is theta. So I have to take a component of S in the direction of M. So I have to draw a perpendicular along this direction. So I extrapolate this. And then I draw 90 degree line here up to here. So this will be S of cos of theta. Right? Up to this is F, up to this is S cos theta. Here W is F multiplied by S cos of theta. Understood? I have this F, the component of S along this direction is S cos theta. This plus multiply these two. They are both parallel, multiply these two, you get the one done. Now the final point. This definition of work, that you take the component of force along the direction of displacement or take the component of displacement along the direction of force and multiply them, you get the work done. This can be written in factorial notation by dot product. We shall not take much time to define this thing. Work can be written as a dot product between F and S. W is F dot S. As the rule of dot product says, whenever you have F dot S, this is what? F S cos theta. What is theta? Theta is the angle between F and S. Theta is the angle between F and S. What is that? The thing. Whatever we are discussing over the time, the theta was what? The theta was the angle between F and S. And here in this formula, F dot S gives you Fs cos of theta. What is theta? Theta is the angle between F and S. So now comes the point that a dot product can be visualized in two ways. Here we have shown two ways to compute the work. And these two ways are related to the two ways of visualizing dot product. These two ways of computing work is related to the two ways of visualizing a dot product. So what is that? How to understand that? vector here. Here is a vector. Say this is B vector. Here is another vector. Say this is A vector. The angle between them is phi. Angle between them is phi. Okay. What is the component of A over the direction of along the direction of B? This. So this is A cos phi. Again, this is B cos phi. So you can draw an arrow here also because you can make it a vector. So dot product is what? A and B. When you take a dot product, take the component of A and the direction of B, then multiply A cos phi by B. The dot product is done. Or take the component of B and the direction of A, which is B cos phi, multiply that by A, done. You get the dot product. These two ways of visualizing or computing a dot product are used in computing work in two ways. Either take the component of F and the direction of S and multiply by S, you get the one, or the other way around. So, my students, I am sure that you have understood the concept of work and how work is defined, how work is computed, whenever force and displacement are parallel, and whenever force and displacement are not parallel. In this simple physics, there are many concepts. You have to understand the concepts. Whenever you master over the concepts, you can progress in physics. Today this much. Thank you very much. Stay at home. Be safe.